Our small mines group is conducting a study of continuous haulage systems. These systems have rapidly increased over the last few years. Recent advances in technology have significantly improved these systems over earlier models, and they have become a common underground haulage method. Current and updated training material in this field is almost non-existent. Therefore, we're visiting many coal mines, gathering information underground, and gaining first-hand experience related to continuous haulage. We also search through related accidents reported by mine operators. Our findings conclude there are many hazards unique to continuous haulage. Hi Thurman, how you doing?
Pretty good. How are you, Greg?
Just fine. MSA's Small Mine Group Initiative is doing a continuous haulage safety program study and would like your opinion on the positives and negatives of continuous haulage. We understand you have them here at your mines.
Yeah, I can tell you why we chose it, Greg. On our car section that we've already got, one thing that we saw was the cars are always having to switch out back behind the miner, and the miner spends 40 to 50% of his time waiting on the next car to get up there. As continuous haulage's name applies, once the haulage system is set up, then it's continuous loading from there on out. So we see about a 30 to 35% improvement in productivity.
For this study, tell me why it's even more important to have correct sight lines.
Well, the main difference is on the haulage section, you've got the haulage system actually running up and down your belt line. And because of that, we've got a 2-foot walkway on the back side of the belt. We've got a 5-foot section of belt structure in there. And then we've got a 9-foot wide continuous haulage section, all trying to be contained in a 20-foot wide entry. And you just don't have any extra width to play with.
Thurman, what are some of the factors in selecting equipment for your mines?
Well, probably the main factor, Greg, was the coal height that we're looking at. And what we ended up with is 48 inches as being our minimum mining height. A couple of the other things we considered, we had to decide which side of the belt entry to put the operator on. And we like to carry our operator on the same side as the belt. Since he's right beside of the belt, he can watch and see if the belt's running. He can watch for bad splices. He can detect coal spills and so forth. The third thing we looked at was we wanted to be able to drive angled crosscuts for 2 reasons. One is it's easier for the miner to turn a brake on an angle rather than hitting head on. And then it's also easier for the bridges to get around the section if they've got angles to turn compared to 90 degrees. With our system, we carry the 10-foot extensions on the bridges, where a lot of people don't do that. Some of the places that have the 30-foot bridges, they can drive 90-degree brakes easier than what we can. They can negotiate these corners easier than what a 39-foot bridge, which is here, what it can. Well, Greg, that's pretty much how we chose our equipment and how we lay our mine out. Here we recognize that the haulage system does bring with it some different circumstances that you have to plan for, but we put safety as the first priority.
Safety is the responsibility of every man that works in the mines. It's the responsibility of anybody that comes underground in the mine.
We cut our crosscuts on 70-degree angles at this mine because the bridge system, you can just make a turn so much easier. The bridges are so long that they'll rub the corners on a 90-degree angle like a regular car section would, and so you need to make the angles at a gentler slope so you can get around them. If not, you can't get around them.
We mine approximately 240 foot wide and maybe 2,000 foot long panels of coal.
All of our mines that we operate all work basically in a 36-inch coal seam. But when you get into lower seams, continuous haulage for us was the only way to go.
So it's proven to be a very safe system for us. And I think a lot of it's attributed to training, to the attitude of the miner, and MSA's inspections.
parts of continuous haulage that we're concerned with are pinch points. We're finding that visibility has a key role in some of the accidents that occur. We're finding that seam heights vary so much that the location of the bridges in relation to the operator and height and width and his distance between the machine itself and the rib, all these play a part. So in a way of speaking, a continuous haulage system, the hazards of it are very unique to itself.
Since 1987, there have been 6 fatalities that occurred on or near continuous haulage systems. 4 classified as power haulage, 2 were roof falls. More than 20 injuries have occurred while crossing over or under mobile bridge carriers. Over 30 injuries occurred while persons were traveling near or doing maintenance around continuous haulage. 4 fatalities and more than 60 injuries occurred due to limited clearance between the coal rib, roof, and other mining equipment. A powered haulage accident occurred when a continuous mining machine and a mobile bridge carrier, MBC, which were connected by a bridge conveyor, were being trammed simultaneously in the outby direction. The MBC operator was fatally crushed between the MBC and the coal rib. In 1994, a powered haulage accident occurred when a mobile bridge carrier operator was pinned between the mobile bridge carrier and the right coal rib. The victim had exited the cab of the number 1 bridge carrier to check the trailing cable or to examine clearance space. The other 3 operators advanced their units forward until all the slack between the conveyors was depleted, causing the unit to pivot toward the right rib and fatally crushing the victim between the mobile bridge unit and the coal rib. Let's review some specifics regarding continuous haulage safety.
The biggest problems we have are pinch points and lack of visibility on the offside of the bridges.
We have to watch everybody around us as well as yourself. We can get in pinch points ourselves, around the structure, because you can cut off a leg or an arm in just a second. And you don't want to mash somebody against the rib either. So you have to watch out. Each one of us has to be alert and watch out for everybody.
Also with the back of the boom, with the front bridge swinging back and forth. So there's a lot of pinch points on the minor plus the offside.
And I found myself pinched against the rib line. It happened very fast. The panic bar did work, but it could have been a lot worse. I got a deep bruise on my thigh. And it took about 3 weeks for it to straighten up, but it was very close. It could have been a lot worse than that.
Traveling up and down by the bridges without notifying the operators. That's the most dangerous thing I see. Pinch points, men getting in the way and stuff.
Anytime that people are moving in or about your bridge, attempting to cross or travel in by it, you want to panic the system out.
Panic bar. Panic bar can save your life in some situations,
The primary safety feature on the bridges is the panic bars. They're instrumental in shutting the entire bridge system off, and not only the bridge that you're on, but the other 3 that's in series with you.
Hold up a minute, Jeff.
It's mainly set up for safety, and your safety and other people's safety around you.
If something happened to his bridge where it became immobile, such as breaking a cat, blow a hose or something, he'll panic it out.
First thing on the bridge, you always panic out when you get off.
If my bridgeman flashed me and want to shut off in a hurry, I just hit my panic bar.
Panic bar. I use that quite often sometimes.
Hold up!
Like I said, with the panic bar, they're designed, if you're operating a machine where you're supposed to be, you're always behind the panic bar, so you're much less likely to get pinched if you're operating in the right spot.
The interlock system that they have on the bridges makes them very safe, so that they must be in good working order, so that if one bridge does have a problem, hit the panic bar and shut the whole thing down and figure out what's wrong and get it taken care of.
If a machine's running a little bit erratic, or if lots of times if you have a lot of moisture in the mine, a lot of buttons will stick, your panic bars will stick, you might get mud under them, you might have a piece of rock fall off the roof. You want to make sure on these continuous haulage equipment where pinpoints are such a major concern that this equipment operates and shuts off when it's supposed to shut off. So one of the things you do when you go in a section on a continuous haulage unit, you want to check and see that your panic bar is working properly, your buttons aren't sticking from moisture or rust, and this holds true especially after a vacation period where the machine's been down a long time. And you want to make sure that your maintenance man, your mechanic on the section, takes care of your problems. When you have a problem on that piece of equipment, you want to make sure that he gets in there and it's taken care of, and don't operate that equipment if it's not working properly. Because when you want that machine down, if you're in a pinch point, you want that machine to shut off. So basically maintain your machines.
If we need to go under the bridge, you'd let both bridge operators to the front and to the rear know that you're crossing underneath the bridge. They can stop their tramming.
The proper way to cross over and under a bridge system is first you get the operator's attention and let him know what you intend to do. Then you wait for confirmation that he has panicked out the system. Now, if you're going to have to go under it in a low cold situation, the carrier needs to be set firmly on the bottom so as the hydraulic failure won't drop the carrier under.
Well, if I was needing to cross over under the bridge, I would make sure the operator knew that I was going to, and that he would panic the system out until I got to the other side, and then flagged him back that I had made it to the other side.
On our bridge system, when people want to cross over, we always panic the system out. We get on the telephone, communicate, tell them what's going on. And then we flag for the individual to come across there who it is, and when they clear, we get the power back on the system, unpanic it, and we call and let them know what's going on.
If a person approaches the bridge system and needs to go across it or under it, they alert the bridge operator closest to them, be it bridge 1 or bridge 4. They get the closest one to them. That bridge operator will panic out the system, get on his telephone and tell the rest of the operators why he has it done. He'll flag the person that approaches. The person will either go over or under. When he gets clear of the bridge, he'll flag the operator back. He'll reset his circuit, get on the phone, tell the operators are ready to go, and they'll start up. They'll restart.
You should be careful that you make sure you know that the person running the machine or equipment knows that you're there. I mean, if you think you're going to be close to that machine, you should, just give him eye contact. Just put your light in his eyes to make him aware that you're there. Even if you just go to crawl beside it, I always like to look like a Dan or a Jimmy or something. I'll look at them so they know I'm there. Because you got this much machinery, anything can happen.
Important part of it is when you're crossing through or under, you must make sure that everybody is aware that you're there. If you're moving past a piece of equipment, you need to know that you let the operator know you're there. Communication, too many times is just not highlighted enough, and I think it's a major part of the whole picture, the safety part, especially in the haulage.
Well, you have to make yourself very visible in this environment.
We have some light signals that we use to communicate with each other. Some of the basic light signals are, of course, the obvious ones, a yes and a no. And one of our main light signals would be to advance, would be in a circle motion.
The type of communications systems they have are primarily the telephones. Secondary, they use their light signals, and in the event of a telephone failure or something, on the spur of the moment, they'll just panic the bridges out and communicate vocally.
Whatever he needs to know back there, I can let him know from the front and tell him when to back up and go frontwards, anything like that.
So communication is really the big thing on that part, because everybody needs to know where everybody else is at. With the noise level that around the equipment when it's running, the chance of you hearing somebody is going to be marginal. So you want to make sure that people see each other and you communicate whatever means. Each crew has their own little set of light signals, and when they go to maneuver in and they maneuver out, it's just a flash of light in a certain direction. They know that they're going to start to back up, or they're going to pull forward.
Like, we got a couple new guys, and they're doing really good, and even they know, when to flag and when not to flag, and how to slow you down, or quick, or just a little bit, or what you need to do.
If they need to take a sledgehammer and bust a rock out of the conveyor, he'll have to let me know so I can shut the miner off and not pinch him in the conveyor or anything.
These things are our communication, And when you're in there, like, you can probably hear them in the background. When they're running, you can't hear somebody talk to you or anything. So you gotta flag, and there's certain things that you do to go forward or back up, and everybody trims up good and get mine cool.
Sight lines tell you this is where you're at and how big your pillars are. You have to have certain size pillars in between each cut.
Well, sight lines is good to keep the belt on centers, and your low and everything need to be, straight, so the belt will run straight and everything.
We have surveyors in here twice a week.
The centers are important to a haulage system, bridge haulage system, because if you ain't got it on centers and keep it on centers, especially in your belt entry, that you long john, you got to have a clearance on your narrow side where your cable runs, and you got to have your clearance on your wide side where your carriers go. And if you don't keep your centers pretty well on and your belt entry and stuff, it makes it tight and it makes it hard for you to get around your corners.
Sight lines are pretty important. If you would get off site, you could well, the main thing I think is just to keep it on sights, because you don't want to make a stump too thin, and then you would weaken the roof too much.
If you get off sites or you're near a gas well or a borderline where you're not supposed to be, if you're not on sites, you're just where you shouldn't be.
Big thing about sight lines, if you're not on sites, there could be a gas well you're going around, there could be old works you could cut into. And sight lines are pretty important, because you get off sites, you say you cut 5 over a little too far. You could be going around a gas well, could be a little off on the map. You ain't real sure. The sight lines are designed to keep you straight, so you can avoid all them kind of problems. So your air connections all come up without having to have a cutback or something like this.
The sight lines are in here for a reason. That is to maintain your proper footage of coal, so you don't mine too much out in one area and not the other. That way the stumps of coal that are left in here support the roof, and that's your protection.
There's nothing that's going to take the full place of that mine stump there, and we intend to keep it where it's supposed to be.
Working as a team it's really important. I mean, you have 10 guys to a crew, and you have to have all 10 guys doing what they're supposed to do. If they don't work as a team and help each other, then your production's you're not going to have none. You'll never be successful. You work together. If one moves forward, you all have to move forward.
So we work together really as a team to reach our goals.
As a continuous haulage operator, you have to work all together. All 4 of you have to work as a team.
The youngest man that we have here has probably been on my crew for about 5 months now, and he's blended in real well.
These men look forward to coming here. All these people are friends, they get along with each other, and I think that works well into safety and with production, because if the men are comfortable and if they're happy and they're satisfied that their environment is safe, they're going to go out and they're going to do a better job for us. They're going to produce that coal.
So everybody has to work together and as a team to get an even steady flow. That's what you want coming up that belt line. You want to just go at an easy, steady flow, so everybody's working together, and
you all have a system you follow.
Just that teamwork is very important. You have to work as a team to be efficient and get your job done and do it safely.
About the Safe Acts program. At first, we had a lot of fun out of these things, because everybody was writing up their buddies. Well, I caught you doing this and I caught you doing that. But, pretty quick we seen it was going to be a very valuable tool that we could use to talk to each other, communicate with each other about, am I doing something wrong, or are you doing something wrong? Something you should correct in your day-to-day work habits. So that's what this is developed into. It's a form of constructive criticism. Your buddies don't get mad if you catch them doing something. They really want to know.
We go over them in our weekly safety meetings and discuss them and go through them where we need to correct them and stuff.
These are also for good acts too. If you see somebody doing something, you know, maybe pulling a piece of draw rock that may fall on someone, you can write that up also.
If we see everybody on the section sort of looks out for each other. If we see someone doing something wrong, then we bring it to their attention. If I'm doing something wrong, they bring it to my attention. You know, we figure that's the best way to do, to keep it in your mind that, you know, everybody at times slips a little bit, and that keeps it in your mind maybe that somebody won't have a serious accident. It's really like the buddy system, everybody look out for everybody.
The safety director, he goes over them all and he picks out the ones he feels most important, and he puts them on a sheet for us, and they talk about them in the safety meetings.
We go to them and try to talk to them about it and show them that they're doing it unsafe and try to help them correct it so we won't have no accident.
Like say, not wearing safety glasses. If you was to be beaten with a hammer and a piece of metal flies off and hits you in the eye, you can't replace your eye after you lose it. That's one reason. And with these safety acts, if you see a man doing an unsafe act, you can tell him about it, call his attention to it.
It is our hope that this small mine training initiative related to continuous haulage safety will be a useful training tool and help eliminate accidents related to continuous haulage systems. Thank you. Program study, and would like your opinion on the positives and negatives of continuous haulage. We understand you have them here at your mines.
Yeah, I can tell you why we chose it, Greg. On our car section that we've already got, one thing that we saw was the cars are always having to switch out back behind the miner, and the miner spends 40 to 50% of his time waiting on the next car to get up there. As continuous haulage's name applies, once the haulage system is set up, then it's continuous loading from there on out. So we see about a 30 to 35% improvement in productivity.
For this study, tell me why it's even more important to have correct sight lines.
Well, the main difference is on the haulage section. Since he's right beside of the belt, he can watch and see if the belt's running. He can watch for bad splices. He can detect coal spills and so forth. The third thing we looked at was we wanted to be able to drive angled crosscuts for two reasons. One is it's easier for the miner to turn a brake on an angle rather than hitting it head on. And then it's also easier for the bridges to get around the section if they've got angles to turn compared to 90 degrees. With our system, we carry the 10-foot extensions on the bridges, where a lot of people don't do that. Some of the places that have the 30-foot bridges, they can drive 90-degree brakes easier than what we can. They can negotiate these corners easier than what a 39-foot bridge.
Non-existent. Therefore, we're visiting many coal mines, gathering information underground, and gaining first-hand experience related to continuous haulage. We also searched through related accidents reported by mine operators. Our findings conclude there are many hazards unique to continuous haulage. Hi Thurman, how you doing?
Pretty good. How are you, Greg?
Just fine. MSA's Small Mine Group Initiative is doing a continuous haulage safety program. Our Small Mines Group is conducting a study of continuous haulage systems. These systems have rapidly increased over the last few years. Recent advances in technology have significantly improved these systems over earlier models, and they have become a common underground haulage method. Current and updated training material in this field is almost...
You've got the haulage system actually running up and down your belt line. And because of that, we've got a 2-foot walkway on the back side of the belt. We've got a 5-foot section of belt structure in there. And then we've got a 9-foot wide continuous haulage section, all trying to be contained in a 20-foot wide entry. And you just don't have any extra width to play with.
Thurman, what are some of the factors in selecting equipment for your mines?
Well, probably the main factor, Greg, was the coal height that we're looking at. And what we ended up with is 48 inches as being our minimum mining height. A couple of the other things we considered, we had to decide which side of the belt entry to put the operator on. And we like to carry our operator on the same side as the belt.